All right, today we're going to cover a very important topic in trigonometry, talking about the bow tie. I don't know if you'll see that in a lot of textbooks that way, but you're going to see why we call it the bow tie. And it's a skill for finding the trig function of any angle. All right, but first, I cannot do the bow tie until I know how to find reference angles. If I'm going to find the reference angle for any angle, then all I have to remember is that I need to get back to the x-axis. So, for example, if I wanted to find the reference angle for an angle that's 145 degrees. We'll call this our first example. If I was given a 145 degree angle and I wanted to find the reference angle, well, we know from the way that we draw angles in trigonometry, we always start here and we rotate this way. There's my 145 degree angle. Well, if I want the reference angle, I just need to bring that angle back to the x-axis in a right triangle like that. And the angle that's going to get me back to the x-axis is this one in here. So it's pretty obvious that this is just 180 minus 145 degrees, which is 35 degrees. So the reference angle for that 145 degree angle is 35 degrees. It's just the angle that gets us back to the x-axis. Does that make sense? No matter where I'm at. So if I had, let's say, as our second example, an angle that was 300 degrees. Well, a 300 degree angle starts here, comes all the way around to here like that. That's my 300 degree angle. But if I want the reference angle, I need the one that's going to get me back to the x-axis, and that's this one in here. So I think it's obviously 360 minus 300. That's obviously 60 degrees. All right, no matter where I'm at, whether it's a positive or negative angle, you just draw it to get back to the x-axis. All right, if I had a negative angle, like negative 225 degrees, that angle would start here and rotate around to here. There's negative 225. Okay? But again, if I want the reference angle, I want the one that's going to get me back just to the x-axis. So that would be a 45 degree angle. We're 45 degrees past 180. All right? That's how we find a reference angle. We need that skill today as we learn how to find the trig function of any angle using what I call the bow tie. And that's what we're going to cover next. And the reason it's called the bow tie is because we're working with triangles that could be in any quadrant. All right? If you look at this little picture, now we're never going to look at 4 triangles at once, but this picture shows us how we draw the triangles, and it's basically what I just did for you with the reference angles. All right? And the only thing that I want to point out on this picture is the places where the x values are positive or the y values are positive and where they're negative. Here, these are positive y values. here, those are positive x values. But down here, those are negative y values. These are negative y values. These are negative x values. And this, of course, is a positive y value. What about the hypotenuses of all of those triangles? They are always positive. Every hypotenuse is always a positive value because of the Pythagorean theorem. I can't take the square root of a negative. All right, so all those hypotenuses are positive values. So, watch how easy it is to find, we're going to do our first example here, the cosine of 240 degrees without a calculator. Now, I will say that to be able to do this, it needs to be one of those common values that we used on the unit circle. Remember all those 30 degrees, 45 degrees, 60s, and all those multiples all the way around? It has to be a multiple of one of those for us to be able to do this. If I would have had the cosine of 217 degrees, we have to use the calculator. All right, we have to use a calculator for that one. But if I have the cosine of 240, that's a multiple of 60, we can do this. All right? So the first thing we do is we basically go to the reference angle. 240 is down here. There's a 240 degree angle. And we do what I just went over, which is find the reference angle. So we're going to draw a right triangle back to the x-axis. I think it's obvious that reference angle is going to be 60, right? Which tells us that this triangle is a 30, 60, 90. You're going to work with one of those two special right triangles on every one of these, either a 30, 60, 90 or a 45, 45, 90. All right? Now let's label it. Remember how we label it with 1, 2, radical 3? The 1 is always opposite the 30 degree angle, but that 1 is a negative 1, remember? And then my 2 is the hypotenuse, and my radical 3 is this leg, but it is a negative radical 3. And now all I do is I borrow this 60 degree angle to find the answer to this problem. So I'm just going to come over to the side and say, okay, what's the cosine of that 60 degree angle right where it sits? The cosine of any angle is the adjacent side over the hypotenuse. So it's going to be negative 1 over 2. So what we did was we borrowed this reference angle to find the answer to the cosine of 240. So we know that the cosine of 240 is negative 1/2. And that is using the Bowtie process. Okay? It's really just about drawing the reference angle correctly, labeling your triangle correctly, and then just doing either adjacent over hypotenuse or opposite over hypotenuse, whatever it may be. Let's do another one. How about the sine of 315 degrees? If I were you, I would pause this video and try this on your own. All right, if you've paused the video and tried it, let's see how you did. A 315 degree angle. We start here. We're going to swing all the way around to here. Remember that we always draw our triangle straight back to the x-axis like that. We're not going to use this angle over here. That's a frowny face. We don't use that angle. All right? We're going to use this angle. All right? So that is a 45 degree angle, which makes this a 45, 4590, right? Which is 1, 1, radical 2. 1, 1, but this 1 over here is negative radical 2. And now we borrow this 45-degree angle to find the answer of this. All right? So I borrow that, and I say, what's the sine of that particular 45-degree angle? Well, sine is opposite over hypotenuse, so that's going to be negative 1 over the square root of 2. When we rationalize that, of course, it's negative radical 2 over 2. So I can say that the sine of 315 is negative radical 2 over 2. All right? Now, what if you saw the cosine of 840 degrees? If you remember in the last unit, we talked about coterminal angles. You remember that I can find a coterminal angle by subtracting 360, and I can do it as many times as I need to. So all we do here is I subtract 360 from this, all right, as many times as I need to get to an angle less than 360. So if I do 840 minus 360, what do I get? 480. That's not far enough. My angle needs to be less than 360. So I subtract 360 again. And I get 120. And now I'm going to do the cosine of 120, which will be the same thing as the cosine of 840. All right, so that's your trick on that problem. So from this point on, it's the regular bow tie process. I draw my 120-degree angle, which is right here. I draw my reference angle back to the x-axis. So this is obviously a 60-degree angle, which makes this a 30, 60, 90, which is 1, 2, radical 3, but this 1 is a negative 1. The 2 is always positive. This square root of 3 is positive. So I borrow this 60-degree angle to find the answer to this. So from that 60-degree angle, adjacent over hypotenuse is negative 1 over 2. So the cosine of 120 is negative 1 over 2, which is also, as we showed, the cosine of 840. All right. Now, just a word about negative angles, and then we'll be done. If you're given a problem with a negative angle, it does not change the process at all. All right? The tangent of negative 135 just means that when I draw my angle, I swing in the negative direction to here. All right? And then I draw my reference angle. This was a negative 135. And I draw my reference triangle back to there. So my reference angle is 45 degrees. All right? And then you just walk through the process. This is a 45, 45. This is negative 1. This is negative 1. This is positive square root of 2. So we borrow this angle. The tangent of this particular angle is opposite over adjacent. So that's negative 1 over negative 1, which is positive 1. So we can say that the tangent of negative 135 is positive 1. Now the only other thing I need to go over is we have not talked about what I call the corners. The 90-degree angles. The 90, the 180, the 270, that kind of thing. So what I do for this is, and there's some greater reasons to why this is true, But I just make a little graph like this, and I just go around the corners for you. I'm going to actually do this in color. So the sine of 0 degrees is 0. The sine of 90 is 1. The sine of 180 is 0. And the sine of 270 is negative 1. So this little graph, remember what this is meaning. This is meaning that the sine of 90 is 1. All right, remember what this is telling you. We don't have to fill all of those in. Now for cosine, cosine are the same values, but it's twisted. For cosine, the cosine of 0 is 1. And the cosine of 90 is 0. And the cosine of 180 is negative 1. And the cosine of 270 is 0. It's the same values, but they have been twisted by 90 degrees or by pi halves. And we'll talk about that some more when we start graphing them. All right? And then tangent. And again, we will talk some more as we go through trigonometry about why this is so. But the tangent of 0 is 0. But the tangent of a 90-degree angle is undefined. And the reason it's undefined is because tangent is technically defined as sine over cosine. We're going to talk about that some more. And this is the place where cosine is equal to 0. And so that means we can't have a 0 in the denominator. It's undefined there. We'll talk some more about that. When we get to the tangent of 180, it's 0. When we get to the tangent of 270, it is also undefined. And we will stop there for today. And that gets you a good start on finding the trig function of